So let's talk about creating an array. An array is an object that holds multiple items of the same type. Okay, so let's look at, so we could do something like this. Int number 1 equals 99. Int number 2 equals 100. Okay, and we could declare a bunch of different variables to hold a bunch of different numbers. But that doesn't make for efficient processing, because I'd have to process number 1 with a line of code and number 2 with a line of code. If I have an array, and we've done arrays before in Java, so you already understand a lot of this. If I have an array, I can use a loop to process it. But I want to talk a little bit about the reference type idea with an array. So when I declare an array, I have to name its data type. So let me do an array of ints. I would say its data type, and then I would use square brackets after it to indicate that it's going to be an array, and then I give it a name. I'm going to call my array my int array. Okay, so this is the declaration part. Since an array is an object, we have to use the new keyword. And then we say int, and maybe I want my array to hold 10 values. Okay. So what happens here? We know that when we declared these, since this was an int, it set aside 32 bits to hold this number. And when I declared int number 2, it set aside 32 bits to hold that number. When I do this, I have to create an array object. Okay, and that array object is going to hold 10 ints. So the compiler goes out into memory and reserves a block of memory, to hold 10 ints. And maybe I'll get 10 out of this, maybe I won't. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 times 32 bits are 320 bits, right? Each one of these is going to be 32 bits. Okay, it sets aside that memory. Now this is the object out in memory. Okay. The variable is a reference. So this variable only holds a reference that points to, and it actually points to the first item in this array. Okay, how do we find the second item? Well, the compiler, when it's running your program, so we know these are numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The compiler, if you want number 3, it can take 32 times 3, add it to this memory location, and jump directly to the third item. Okay, because we know that the size of these are all consistent. And we know they are contained in a continuous block of memory. Okay, so we know that this one, item index 1 starts 32 bits after the item at index 0. This is 32 bits after that. Item 3 is 32 bits after that, and so on and so forth. So it's easy to find where the different numbers are stored with their index numbers by multiplying the size of the type, in this case 32 bits, times the index we're looking for, and that points to where that's at in memory when we add it to the initial reference. Okay, so that's how the memory allocation takes place. So let's actually do some programming and put this into practice.